This is a very fast version of the lecture from Tuesday, December the 1st, since my internet went down. So I'll try to give you the highlights and all the pages that we went over. First from the book, key items from the book. Representation of functions as power series. Okay, here's 1 over 1 minus x. Treat this as a geometric series. First term is 1, common ratio is x, so it's 1 plus x squared plus x cubed. It's equal to this. You don't have to memorize it. You can put this on your cheat sheet if you wish. Okay, we're going to do term by term differentiation and integration. Page 754. Key item is here. The basic idea is if you have this infinite polynomial, how do you take the derivative? Just derivative, differentiate term by term. How do you integrate term by term? The radius of convergence stays the same. So if the original radius of convergence was r, when you differentiate or integrate, you still have the same radius of convergence of r. Then 11.10, which I'm not really going over, but I was sharing with the class because I need next time. Okay, so page 760, a typical Taylor series expansion is like this, and this is a Maclaurin series. A Maclaurin series is centered at 0. Taylor series are centered at A in general. Taylor's inequality, page 762. This formula here. When I do the problems in class, I'm actually going to replace the m with this. It says absolute value of this thing is less than or equal to m. I'm going to put it here. You're basically taking the n plus first derivative exponent factorial. Okay. And then this is a key chart. So put this on your cheat sheet, page 768. This one, this one, this one, this one, and this one. You don't need the last two as much. Definitely not the last one. If you want to put this second to the last one, you can. So e to the x, sine x, cosine x, inverse tangent x, ln 1 plus x. Put that on your cheat sheet from page 768. Right, now for problems from 11.9. Again, keep in mind that my problems may not match yours. Right, so we're differentiating and integration power series, these infinite polynomials. Okay. Key formula from a geometric series. S, the geometric series sum, is a over 1 minus r if absolute value of r is less than 1. Okay, so 1 over 1 minus x, if the first term is 1, common ratio is x, that's 1 plus x squared plus x cubed. Okay. The Melvin-Hom rule is write at least 4 terms of a series in your final answer. Final answer should have 4 terms. Okay. All right, so 1 over 1 plus x, you can treat it as 1 over 1 minus a negative x. So the first term is 1, the common ratio is negative x. So 1 minus x plus x squared minus x cubed. If I were to integrate both sides, integrate term by term, this is ln absolute value of 1 plus x equals c plus integrate 1, you get x. Integrate that, negative x squared over 2, plus x cubed over 3, and so on. Plug in 0, 0, 0, 0. You have ln of 1 is equal to c, where c is 0. So here's ln absolute value of 1 plus x. X minus x squared over 2 plus x cubed over 3 minus x to the 4th over 4. Since the radius of convergence is 1, that means you're only allowed to plug in stuff between negative 1 and 1. Well, if I plug in a number between negative 1 and 1, this isn't going to be negative, so I can change it to parentheses. Okay, in particular, if I plug in 1 now, I get ln 2 is 1 minus a half plus 1/3 minus a 4th. And I mentioned earlier that this is the alternating harmonic series. It converges to natural log of 2. It's about 0.693. And other thing I showed you in class, 1 over 1 plus x squared. Okay, you want to make it look like this. So 1 over 1 minus a negative x squared. So a is 1, common ratio of negative x squared. Okay, this will converge if absolute value of negative x squared is less than 1. That means x is less than 1, so the radius converges is 1. So I can write 1 over 1 plus x squared as a geometric series, 1 minus x squared plus x to the 4th minus x to the 6th. Integrate both sides, integral of that, integral of that. This is inverse tangent of x, c plus x minus x cubed over 3 plus x to the 5th over 5 minus x to the 7th over 7, and so on. Okay, if I plug in 0 for x, inverse tangent of 0, c plus 0 minus 0, these are all zeros, and inverse tangent of 0 is 0, so c is 0. So here's a formula for inverse tangent of x that was on that, that formula sheet page that I showed you that had sine, cosine, e to the x, inverse tangent. Here's that. Okay, you don't have to memorize it. This was from my previous class, but for you guys, you don't have to memorize it. In particular, if you plug in 1, you get this. All the numerators are 1. Okay, that converges by the alternating series test. But the inverse tangent of 1 is pi over 4. If you multiply both sides by 4, you have this nice formula for pi. You don't have to memorize it. It's just a curiosity. Pi is equal to 4 times 1 minus a third plus 1/5 minus 1/7. You can get as many digits of pi as you want. A computer can do this very easily. Just keep going and get as many digits of pi as you want. So here's a formula for pi. Here's a formula for ln of 2. All right, so for actual problems, number 3, sort of just rehashing what we did before. 1 over 1 plus x, think of it as 1 over 1 minus a negative x. So common ratio is negative x, so 1 minus x plus x squared minus x cubed, and so on. Radius of convergence is 1, because again, this is my r. The series will converge if absolute value of r is less than 1. Absolute value of negative x is the same as absolute value of x. So radius of convergence is 1. Okay, the interval of convergence is -1, 1. If I plug in -1, I get that. That diverges by test for divergence. If I plug in +1 into here, I get that. That also diverges by the test for divergence. Okay, now number 5, you have to make the bottom look like 1 minus r. In order to do that, you factor out the 3 in the denominator. So at the beginning, it's 3 parentheses 1 minus x over 3. And then you divide top and bottom by 3. So it looks like this, 2/3 divided by 1 minus x over 3. So that's my a, that's my r. Okay. By the way, you can check. If you multiply top and bottom by 3, you do get indeed that back all over again. Okay, so this is my common ratio, x over 3. You set that to be less than 1 multiplied by 3. Absolute value of x is less than 3, so the radius of convergence is 3. Okay, write down at least 4 terms. So the first term is 2/3, then you keep multiplying by x over 3. So multiply this by x over 3, you get that. Multiply that by x over 3, you get that. Multiply that by x over 3, you get that. So there we are. Okay, number 9. F of x is 1 plus x over 1 minus x. Think of this as your a, and x is your r. So it already looks like this. Right? This is your a over 1 minus r. So the radius of convergence is 1. The absolute value of x is less than 1, means r is 1. So the first term is 1 plus x. Then you keep multiplying by x. So 1 plus x times x, 1 plus x times x squared, 1 plus x times x cubed. Okay, so multiply that by x, you get that. Multiply that by x, you get that. Multiply that by x, you get that. Okay, clean it up a little bit. You get 1 plus x. This becomes plus x squared. This becomes x squared plus x cubed, and so on. And you notice you actually have 2x squared, 2x cubed, and so on. So here's at least 4 terms of the power series representation that I want. 13, the way you get this is you differentiate 1 over 1 plus x, and it'll almost be this. All right, so 1 over 1 plus x we know is this. We've seen that before. Okay. Now, in the overall problem for 13, I have to differentiate twice. Every time you differentiate, you lose a constant. So I'm actually going to write 6 terms, 1, 2, 3, 4, 5, 6. Because when I differentiate, I'm going to lose that. I only have 5 terms left. So 1 over 1 plus x prime is the derivative of all this, differentiate term by term. So the derivative of this, think of it as 1 plus x to the -1. That'll be -1, 1 plus x to the -2. Differentiate all that, that's nothing. -1 plus 2x minus 3x squared plus 4x cubed minus 5x to the 4th. Multiply both sides by -1, and you have the answer to part A. 1 over 1 plus x squared is all this. Radius of convergence is 1. Okay, differentiate again both sides. Treat this as 1 plus x at -2. So the derivative of the left side is -2, 1 plus x at -3rd. Derivative of that is 0. That's -2, 6x minus 12x squared plus 20x cubed, and so on. Divide both sides by -2. And 1 over 1 plus x cubed is 1 minus 3x plus 6x squared minus 10x cubed. Notice I still have 4 terms here. Okay, that came because I started with 6 terms, and every time I differentiated, I lost a constant. If you started with just the 4 terms at the beginning, after 2 derivatives, you'd only have 2 terms. But if I started with 6, now I have the 4 required. Part C, simply multiply both sides by x squared. So x squared times that is this. Multiply all of these by x squared, so it comes out to be this. Okay. All right, then next one I'll show you is 15. ln of 5 minus x. Start off with 1 over 5 minus x, because I know the integral of this is going to be almost that. Okay, so we need a 1 in front. I don't want the 5, so factor out the 5. You write it as 5 parentheses 1 minus x over 5. Okay. 5 times 1 is 5. 5 times negative x over 5 is negative x. Then divide top and bottom by 5, so it looks like this. Now it looks like a over 1 minus r. And again, if you want to double check, multiply top and bottom by 5, you'll get this. So that's my a, that's my common ratio. So 1/5 plus x over 25 plus x squared over 125 plus x cubed over 625 and so on. Okay, you want absolute value of x over 5 to be less than 1. Multiply both sides by 5, you get that. So the radius of convergence is 5. Okay, now we integrate both sides. So the integral of this, which really means the integral of 1 over 5 minus x, is the integral of all that. Okay, this is negative ln absolute value of 5 minus x by the chain rule. Okay, you have to multiply by an extra negative 1. So c plus 1/5 x plus x squared over 2 times 25 plus x cubed over 3 times 125, x to the 4th over 4 times 625, and so on. Clean up the denominators. That's 50, 375, 2500. Okay, now I plug in x is 0. Put a 0 there, 0, 0, 0, 0. C is equal to negative ln 5. So put negative ln 5 right there. Here's negative ln parentheses 5 minus x. Same trick as before. I have the bars, but I'm centered at 0. If my radius of convergence is 5, that means I can only plug in stuff between negative 5 and 5. If you plug in any number here between negative 5 and 5, this expression will never be negative, so I can drop the bars, make it parentheses. All right, then simply multiply both sides by negative 1, and you're done. So here's ln of 5 minus x, which is what the problem asks for. ln 5, all of these become negative. So negative x over 5 minus x squared over 50 minus x cubed over 375 minus x to the 4th over 2500, and so on. Okay, 19, to get this, begin with 1 over 1 minus x. Okay, that's 1 plus x squared plus x cubed plus x to the 4th. I put 5 terms because I know I have to differentiate once to get that. Okay, so differentiate both sides. Treat this as 1 minus x at negative 1. So the derivative is negative 1, 1 minus x at negative 2 times negative 1 by the chain root. That is exactly 1 over 1 minus x squared. That's what I want. So the derivative of all this stuff, derivative of 1 is 0, derivative of that is 1, derivative of that is 2x, 3x squared, 4x cubed. Okay, and now I just simply multiply both sides by 1 plus x. So multiply this by 1 plus x, I get that. That's what I'm looking for. And multiply all of this stuff by 1 plus x. So 1 times 1 plus x, plus 2x times 1 plus x, 3x squared times 1 plus x, and so on. And then if you multiply all of this stuff out, okay, it ends up looking like this. 1 plus 3x plus 5x squared plus 7x cubed plus dot, dot, dot. That's at least 4 terms. Okay. You can stop there. You don't have to make this. In class, I went ahead and made this up. Summation n equals 0 to infinity of 2n plus 1 x to the n. I know sometimes it's hard, so you can just stop right there. Okay. 21. Turn this around. 16 plus x squared. Factor out the 16. Right, so we've seen that now. It's 16 times 1 plus x squared over 16. Divide top and bottom by 16. So x over 16 over 1 minus a minus x squared over 16. Okay, so that's my a. That's my common ratio. So first term is x over 16. Then you multiply by negative x squared over 16. You get that. Multiply that by negative x squared over 16. You get that. And multiply that by negative x squared over 16. Looks like that. So here's 4 terms. Radius of convergence is 4. Okay, because if you want this thing to be less than 1 in absolute value, then x should be 4 or less. Okay, 23 is a little bit harder. Break it into S1 and S2. S1 is ln 1 plus x. S2 is negative ln 1 minus x. Okay, so both of these come from integrating 1 over 1 plus x or 1 over 1 minus x. Okay, so 1 over 1 plus x, again, think of it like that. So it's 1 minus x plus x squared minus x cubed. Again, a over 1 minus r. Integrate both sides, so it's a recurring theme. This becomes ln absolute 1 plus x. C plus x minus x squared over 2 plus x cubed over 3 minus x to the 4th over 4. Plug in 0. ln 1 is c plus 0 minus 0. So c is equal to 0, which is ln 1. And again, drop the bars. So we already know this is ln 1 plus x. That's S1. Okay, work on S2. Let's look at integral of 1 over 1 minus x. Again, treat it as a geometric series. First term is 1, common ratio is x. 1 plus x squared plus x cubed. Okay. If I integrate, it's ln absolute 1 minus x times negative 1. That's perfect. I was looking for the negative in front anyway. C plus x squared over 2 plus x cubed over 3 plus x to the 4th over 4. Okay, let x equal 0. I get negative ln 1, which is 0. C plus 0, 0, 0. So C is equal to 0. So here's negative ln absolute 1 minus x. Again, the radius of convergence is 1, which means I can only plug in stuff between negative 1 and 1. If you plug in stuff between negative 1 and 1, this thing's never negative, so put it in parentheses. So finally, S1 plus S2, I add these up. So I put the series expansion for the first one, which is that, x minus x squared over 2 plus x cubed over 3 minus x to the 4th over 4. And then the series expansion for the second one is that. If I add them up, notice the even ones cancel out. Okay, x plus x is 2x. X cubed over 3 plus x cubed over 3 is 2x cubed over 3. Okay. If I stop right here, that doesn't fit the Melvin-Helm requirement of only having 2 terms, but you can see from the pattern, all the odd ones are going to be doubled times 2, even ones will drop out. So it's going to be 2x plus 2x cubed over 3 plus 2x to the 5th over 5 plus 2x to the 7th over 7. Okay, how do you integrate t over 1 minus t to the 8th? Okay, this can't be done by conventional means, but treat it as an infinite series. First term is t, common ratio is t to the 8th. So put t, then you keep multiplying by t to the 8th, that. Multiply that by t to the 8th, that, and that. So that's easy. C plus t squared over 2, t to the 10th over 10, t to the 18th over 18, t to the 26 over 26. Okay, 27, again, it's my 27, x squared ln 1 plus x. So start off by figuring out ln 1 plus x, which is the integral of 1 over 1 plus x. 1 over 1 minus a minus x. 1 minus x plus x squared minus x cubed. Okay, so integrate ln absolute 1 plus x is all that. We've seen this before. Plug in 0, c is 0. So ln 1 plus x is all that. Multiply both sides by x squared. I have to make it look like that. So x squared ln 1 plus x. Multiply each of these by x squared. You get x cubed minus x to the 4th over 2 minus plus x to the 5th over 3 plus minus x to the 6th over 4. And then I integrate. Okay, so I integrate both sides. C plus x to the 4th over 4 minus x to the 5th over 5 times 2, x to the 6th over 6 times 3, x to the 7th over 7 times 4. So final answer is C plus x to the 4th over 4 minus x to the 5th over 10 plus x to the 6th over 18 minus x to the 7th over 28. Okay, some integral problems. Okay, evaluate to 6 decimal places. So treat this as 1 over 1 minus negative x to the 5th dx. So the first term is 1. The common ratio is negative x to the 5th. So 1 minus x to the 5th. Multiply that by negative x to the 5th, you get that. Multiply that by negative x to the 5th, you get that. Okay, integrate. So x minus x to the 6th over 6 plus x to the 11th over 11 minus x to the 16th over 16. Notice when you plug in 0, they're all 0. Plug in 0.2. Looks like this. This will converge by the alternating series test. So by the alternating series estimation theorem, if I stop anywhere, the error is no more than the next term. We were asked to find accuracy to 6 decimal places. That's 0.000001 or 10 to the minus 6. So I have to find a term that's smaller than 10 to the minus 6. Here it is. This one comes out to be 2 times 10 to the negative 9. So all I have to do is add the first 2 terms. And to 6 decimal places, 0.199989. Okay. Then finally, 33, they want you to evaluate arctan of 0.2 to 5 decimal places. So here's the rule for arctangent. Plug in 0.2, 0.2 to the 1 over 1, 0.2 cubed over 3, and so on. This will converge by the alternating series test. By the alternating series estimation theorem, we want accuracy to within 10 to the minus 5. So we need to find a term that's smaller than that. Here's a term that's smaller than that. So this one is 1.9 times 10 to the negative 6. So just punch this in your calculator, and it'll be correct to 5 decimal places, 0.19740. Right, so that was a hurried version of the lecture from yesterday, Tuesday, December the 1st.